So yeah, welcome. Thanks for being here. So I am going to talk today about building a vendor-agnostic IAM platform using Crossplane. So let's dive right into things. Here on the left, we have a certain number of users, certain developers, which want to access the services on the right hand. So a few examples of AWS, Grafana, GitLab, and so on. And now the issue or the challenge with giving permissions to user is that users have, or users are grouped within teams, and teams have certain roles, certain functionality. So certain users within a team have a certain set of permissions, getting access to a certain set of services with the appropriate permissions. So yeah, that's the overall thing. And then there are also some users which need some special permissions, and with that it gets quite complex very fast. So it's also questions like, what permissions do I have in all these services? What permissions does a colleague have because he's able to do something, am I not? So especially in the cloud environment, can be a frustrating question to answer. Also, when you're getting started in a new company as external contractor or as new employee, the first day, most of the time, is just asking for permission. So can I access that service? Can I get access to this service? And so on. Yeah, and also the question, who is managing the services and so on. So a lot of questions which are hard to answer if all these permission management are distributed. And it's not also complex on the organizational side. Also the services, like here, you don't only have one AWS account, you have multiple. So you need different permissions for those. Or you have multiple monitoring tools, so not only Grafana. You have multiple source control management systems, so not only GitLab, but also like issue tracking, so project management, documentation, and so on. So on the right, the number of services is probably a couple of dozen, and so on. So yeah, not an easy task to do. And this is something we want to tackle in this talk today. So yeah, short commercial break. My name is Stefan Möhrle. I'm the founder and DevOps engineer of CoreWire. We are a small company based in Freiburg. We are doing training and consulting. And the main focus we have is DevOps and cloud computing. Today we are here because of Fastlane, which is our partner. They also have a stand here, so they are the training provider giving worldwide technical trainings. Yeah, they are also sponsoring the location on Wednesday for the workshops. And then lastly, our customer Reservix. So if you are interested in that system we have built, if you want to work with that team that has built that system, they are hiring DevOps engineers if you are interested. So yeah, commercial break over. So now let's start. So the starting point. So we went to our customer and they had the following system. So they had a central keycloak, so a single sign-on system, had the services behind, and all the developers had to go through the keycloak and got their permissions there. So far, so easy. Then from the management point of view, we had a few parts which were managed by Terraform. So there was already infrastructure in code as code in place. And a few things were done manually. So getting access to GitLab, for example, you had to go to the specific person and then get your permissions. So a few good things about that is we had a centralized location with Keycloak to see what kind of services are active and what kind of service you could use. Also infrastructure as code, so a bit of automation was already in place, but the downsides were it was distributed across many repositories, so it was historically grown. Things were done manually, and also the Terraform modules were not as flexible as they should be. So as you have seen in the first slide, teams grow and you have the need for more than a specific number of roles. And there was the thing that it was just limited to 4, and that was kind of inflexible, leading to the thing that some people couldn't get access for systems, or the other choice was giving more than this one person access to the system. So you had to give too much permissions to certain systems because of that inflexibility. Yeah, and that's something we want to tackle. So that's the starting point. Then we sit down and thought about the solution. So how could we fix that? How could we make that better? And the first thing was we want to have a centralized location. So we want to have a single source of truth, like in the GitOps style. So we always know what is the state of the service by just looking into that system or in that repository. Okay, and then was the first question, how can we make sure that that state we are defining in that repository is also reflected in the services? And this is where we are have tested and introduced Crossplane with Kubernetes. So Crossplane has some similarities with Terraform. It's also infrastructure as code. You're defining your desired state, and the system itself is then trying to achieve that desired state to reflect what you actually wanted. Yeah. But a few benefits of Crossplane over Terraform is it's cloud native or it's Kubernetes native. So we have some features which help us to continuously apply that state. So with Terraform, if you do manual changes, you only recognize those manual changes after you try to apply that plan again. With Crossplane, you have that continuous application. So whenever something changes, the desired state will again be applied onto the actual system. So that's the first thing. And then the second thing is how can we sync our repository to the Kubernetes resources we have to create. And therefore, we are using Argo. So we always have that state reflected in Crossplane. Okay, so that's the technical side behind. So how can we make sure that the single source of truth and these services reflect the same state? And then another thing is, how can we change permissions? So in the first step, operators, so people who are able to handle a Git repository, had to make manual changes on text files, and also developers could read their permissions out of those repositories. But that was just the first part, since we have focused on building the system behind the repository. In the second step, we started to introduce a web app which visually enhances the permissions. So you can just click through, you can see what users have on permissions, and also write back in the second step, so the operators can write back the permissions into the system. And then the system itself, so the web application, can also be permissioned, or the permission can be given by the Crossplane setup itself. So yeah, then they have easy access for that. Okay, then very short on Terraform and Crossplane. So assuming you know Terraform, then the left part should be easy. So you have your providers, you have your resources, you define the resources. Here in the example, it's an AWS IAM user. You give it a name, potentially some more parameters, and then you can make Terraform apply. Crossplane is, in that sense, basically the same. Now you're writing YAML files, so custom resources, and not the HashiCorp configuration language. But the information you have to provide is basically the same. So you're giving the name, you're giving the resource by using a specific API. So here it's the IAM AWS crossplane.io, and the kind is the user. But yeah, in essence, so what you have to provide to define your desired state is the same. Okay, and now we have defined our target. So what is the architecture we want to have? We have our current state. So how do we transition into that new state? So the users don't recognize that change in the running system, because they still have to have access to their systems to be able to work. So it has to be a silent change. And therefore, yeah, here on the middle, we have the developers going to Keycloak, which is managed by Terraform, and then going to the services, which are either managed by Terraform or manually. And on the side, we have now our single source of truth, the Git repository with the Crossplane management service, management cluster with Crossplane, and Crossplane should take over control of Keycloak and the services. So in the first step, we took over full control over Keycloak, because that was an easy change in the sense of, if we keep the roles which are provided via OIDC or via SAML are the same, then there is no difference for the systems behind the single sign-on. And then in the second step, we can start to migrate each service one by one, and then we have that full control over the whole span. So we can define in our repository users, what kind of roles they have, also what kind of roles Keycloak is sending basically to the client, and we can also configure what the client should do when the client receives those roles. So yeah, we have the single place where we can define those, and then the information is distributed over the systems which need to be configured. Okay, so that's now the plan. How we get to the goal state and what the goal state is. Now getting a bit deeper into the individual parts. So the cross-plane providers, they are the crucial point because we need them to manage the systems. So yeah, let's have a look into them. So Crossplane installs some custom resource definitions. One of those custom resource definitions is a provider. So we are just creating that provider by kubectl apply, and then Crossplane is creating this provider. Provider could be for AWS, for the GC Cloud, for Azure, but also like for Keycloak or for Grafana or for GitLab and so on. And these providers itself will bring some custom resource definitions with them. So in a Terraform sense, we have the resources like an S3 bucket, an IAM user, an IAM policy, IAM role, or in Keycloak we have also a user, a client mappings, and so on. And these are all reflected now in custom resource definitions. And all we have to create is those custom resources. So one custom resource for each user, one custom resource for each group, for each group membership, and so on. And then Crossplane can reflect that state back into the system. So yeah, then the provider is taking over and is applying that to the system. And now the interesting, or the most interesting or important part is what kind of providers do we have? So what kind of systems can we configure? And the first place is there's a marketplace by Upbound where you can get some basic providers for AWS, Azure, and the big cloud providers, and a few more. And the other important thing is you can convert any existing Terraform provider. So Crossplane is able to get access to the systems by leveraging the vast library of Terraform. And this is also what we have done with that Keycloak provider. So when we started, there wasn't any provider for Keycloak for Crossplane, but there is a quite good provider from Terraform for Keycloak. And then we use that repository to generate that Crossplane provider, and we are currently in the process of handing that over to the Crossplane contrib library on GitHub, so everybody else can use that as well. But in that sense, you have quite a lot of options because you can, you have that fallback on the Terraform providers, which exist for many systems. Okay. Then next step, so now we have figured out how we can use Crossplane to configure all the systems we want to configure. The first part is now how do we get the state in the repository into the Crossplane system or in the custom resources. And here, as a short reminder, the crucial part here is to be as flexible as possible. So we have users in teams with different roles. They need to have a certain kind of permissions. We have to be able to create new teams or to create new roles. Maybe reuse some components to give some extra permissions to certain users. So since teams grow, since organizers are reshuffled, that part should be as flexible as possible. So we are really getting a benefit out of that system. And yeah, that's what we are going to do by using Helm. There's one icon missing. So on the left, we have the value files for Helm when we use the templating language to generate the custom resources. The benefit is that the value files, so I will show some examples for the value files. We have complete control over the structure, so we don't have to in the later case or in the old case write any Terraform, so we don't need to know how that structure is, and we are not limited by that. We can just define our own structure, and then the Helm templating language is generating those custom resources for us. So yeah, there are some examples now. So first example is a value file where we're defining the units. Units are somewhat of a team, so we changed some of the terminology, or that was the terminology already used. So there's an authentication team, there's a billing team, there's a reporting team, and then for each of those units or teams, we can define certain things. So we have here, for the auth team, the AWS client disabled, so they're not able to log into AWS. They can only configure their keycloak, for example. Then we have the group section, where we can add groups or create groups by just adding items to that list. We have to reference the members and also the roles. So roles are those reusable components. Could be either specific roles for the clients, can be realm-wide roles in the keycloak sense. So all the developers, for example, get access to certain resources like the Wi-Fi password for the office location and so on. Yeah, so that's how we can define that. Also, besides this file, we have a few more files. One file defines the clients, one file defines the roles. At all stages, we are able to define some defaults. And as you can see here, we can override those defaults. For example, in the clients, we can say, should that client be enabled for all the units? And if we do not want to have that default behavior, we can override that default behavior in certain locations. Yeah, and by having all these informations, we got into one problem that the the Crossplane resources or generation of Crossplane resources got quite complex, because the Helm templates got quite complex, and this is where we then introduced an intermediate step. So we use Helm in 2 stages. So first, we are generating some global values, which predefine or pre-calculate all the resources we require, so generating some names, generating lists, and then in the second stage we only have to transform those lists into the appropriate Crossplane resources. So yeah, then the most part of the computation is on the first arrow, and the second one is just a simple translation. Yeah. And for that, just a few examples. I will also show it in a demo if I can, so if everything's working. So in the global file, we now define a value KC, which stands for keycloak. Then we do that calculation, so we create a variable $KC with a few fields. Then we populate those fields, and in the last step, we are writing out that variable as YAML, and then in all the templates, we can then use these predefined values. So here we are creating roles for keycloak, and basically here we only have to iterate over a single variable to get all the relevant information. And in that part is no more logic, so that's just an easy translation. And the other part is then also, as we will see in a second, very clean and testable, and we can make sure that any changes to the system won't kill any of the permissions of the users. So that's also a crucial point. So if we do any changes and then users do not have access to the system, so that's something we really want to avoid. Okay. So yeah, then last part on that thing is the testability. So how can we make sure that the system behaves as we want? So how can we make sure that we do not accidentally revoke any permissions from users? And this is also where these 2 steps come into favor. So most of the calculations happen in the first part, so the transformation into those predefined, pre-calculated variables. And this is just YAML in, YAML out, so that's easily testable by unit test and regression test. So we can easily make sure that there are no silent changes we don't want to introduce. And then the second part is just that simple transformation where not a lot of logic is built in anymore. Then what we further have is schema validation, so we can make sure, since people in the first place have to edit the files by hand, and later the web app should do that. We have a schema validation, so that only valid changes can be introduced in the GitLab and a Git repository. So this is where we use a short Python script with Pydantic. And then the last thing is we also have end-to-end tests where we, in our test system, can look into the state, what is the desired state, and then use some clients for the application, so a client for Keycloak, a client for Grafana, and so on, and check if the actual state is represented in the test systems, and therefore having those end-to-end tests as well. Okay, so this is already the main part. I'm now going to try to do the demo. Yeah, just for reference, I can only see your screen, so on my screen I don't see anything. So yeah, let's see if everything's working. Okay. So I have opened the project in itself. So here we have the Helm chart and the value files in one project. In a production system, you would only have the value files, but that shouldn't matter currently. So yeah, what we can see here is the unit files. We have a very simple structure, so the demo is really stripped down. In the demo, we can only configure Keycloak, so no services behind, and we have a Grafana in the back to test that single sign-on. But here it's just the stripped down version with only those two systems. So yeah, we have here defined groups, so YAML engineers and the code monkeys with a few members. And also here are the roles and the clients defined. And then later we have the global variables here. So this is basically the main part of all the logic, where you can see that's also the snippet of the slides. So we are defining the KC values, doing some pre-calculations, generating names, checking if roles should be active or not, and then as you can see, it's quite a bit. Also, that's why it's really important to have those unit tests so you can see if there are any changes which you didn't want to introduce. And then the last thing is these to YAML of the KC, and then you can render that. It's also something we can render. So we can directly see in the development phase. So we are rendering here the config map, which is just printing out that KC variable. We can see now, okay, what are active roles, what are the clients, and so on. So in most of the time, you're just writing those template up here and then checking in that KC value if the changes are as you wanted. Okay, and then we can actually I have prepared something like this. Exactly, so here is a small merge request where I now moved that user 1 out of the code monkeys and moved into a new group. So I'm creating a new group with that user 1, and now the user should only have guest rights, so only have viewing rights for Grafana in that case. And with that, I can also show you that small web application. So it's basically a prototype at the moment, but it already has some purpose. So you can see, for example, user 1 is part of the infrastructure team, is part of the group code monkeys and the effective role. So if there are more services now here, so in the real system there are more services here down here, you can see what kind of rights that system has or the user has in that system. Also, you can check for your colleagues. So currently you can see the permissions of all users. And then lastly, what also was a change which we had to do while developing is to see what an actual merge request would change in the system. So that merge request I showed you just on the other tab has also an entry here, and that entry is now showing what things are changing. So who is the author, when was the merge request created? We have some metadata on what is changing, and also we have some detailed things so you can see, okay, if I introduce that change, what will actually happen in the system, so that also the operators can be sure that they don't make any changes they want to. So you have the diff views here, also for the units and here for the user. So you can see user 1 has that field groups by unit, and now for the unit infrastructure team, the CodeMonkey group is replaced by just visiting, and also the roles by client is changed from editor to viewer. So that's it. And if we are satisfied with that, we can merge that thing. And then let's see if everything... Yeah, we have here now that ArgoCD, which is listening on the changes in that repository. And now we can see there are some things out of sync. And after a few seconds, or after less than a second, everything is in sync again. And you can see here the memberships, the roles, all the custom resources which are created. And these are then reflected also in the system here. And then lastly, going to the single sign-on. Now the password is not set anymore. Okay, so that's the part where the demo breaks because I had to restart. And now if I would log in with Grafana with the user 1, which doesn't have a password at the moment, then I would see that now the things have changed, so the permissions have changed. Yeah, but the main part is we have now that end-to-end control over the systems, and can also integrate all the other systems. So for example, with AWS, you can define for each user what kind of access he or she should have to the accounts, and also what kind of permissions. So you can even define policies which you can then assign to their roles, which they assume by logging in with SAML and so on. And that's that end-to-end approach. Yeah, with that, I think that's it, at least what I can show you in the demo part. And yeah, with that, that's concluding the talk, and we can, after some questions, go on lunch break.
Cool, thank you, Stefan. I think deserves a round of applause for dealing with the demo gods over there. Sometimes they're kind, sometimes they're not. They weren't too bad today. We do have a few questions. Is there a way to delegate permissions, maybe temporarily?
So at the moment, not really. So because it's in that state where we just, we have that repository, and only operators which have write permissions to the repository are able to do so. But in the next step, the web app should be enhanced with also that writing capabilities. Then you can delegate the permission management to certain users, and there you could also add features like removing roles after a certain amount of time. So that's up to automation. So since we are completely free in defining that state in our Git repository, features like that can be added quite easily.
Cool. How do you enforce access control at the Git repository level? So a user can just create. So a user just can't create any resources via Crossplane.
So yeah, users who have access to that repository are able to completely change the permissions. So that's a point where you have to really make sure who can access that, and that's why the web app is in place, which can handle the permissions for certain users, because Git permissions for a Git repository are not fine granular enough. So that's also the reason why we need something on top of that.
Yeah, definitely. Next one. Why not using mechanics like Active Directory? Most of the tools needed for DevOps management software lifecycle are supporting mechanics like that, even AWS.
So yeah, the requirement of the customer was to not do that. So that wasn't an option there.
Yeah, I guess you also have to go with the customer, and there are different tools, different people enjoy using different tools.
It's not always technical reasons.
No. Terraform state is stored in plain files while Crossplane in etcd. What failure scenarios did you encounter, and how does Crossplane deal with it? Full, partial?
So we had some problems where we wanted to upgrade the provider, and the provider didn't upgrade well, and then the mapping was broken, so of the custom resources and the actual link to the files. But actually, that was quite robust. We could just delete the provider and then reinstall everything, and then what we had to do was in the resources, they add some tags, some annotations, which reference the actual objects in the target system. And if you delete them, so these IDs, then there's a reconfiguration, and then everything worked again. So that was quite nice. And since the state which is in etcd stored is easily generated by our Helm chart, if that's gone, we can just regenerate it within parts of a second.
Simple push. And a simple push.
Yeah,
and it's
or just an Argo sync. So just do a resync and that's it.
Have you ever had problems with broken Crossplane provider, i.e. after an update that messed up created resources, which I think you just replied to, unless you want to go into more detail.
That's fine, I think.
Do you still have Keycloak active?
Yes, it's still active. So that's still the main the main login point for the developers.
I'll keep on going until people shout and say food. Was Keycloak operator an option for you instead of Crossplane?
So you mean, operating Keycloak with the operator. Yeah, that was something we thought of, but the thing is there we do not have the end-to-end approach. So with Crossplane, we have that one system that can configure the permissions over multiple services. So it's up to us which service we are introducing, because we have to add that provider, we have to add that creation of the custom resources. But in that sense, it's a single system where we can have that end-to-end approach.
Cool. I'll do maybe one more. And then, do you use Crossplane compositions?
At the moment not. We have thought of that, but currently it's not planned.
And I feel like somebody really likes Active Directory. This is the last one. Would Active Directory also be a viable solution if the customer had not excluded it?
Since my knowledge about Active Directory is not that deep, I cannot do that comparison.
Yeah, fair enough. There was a question about Helm and syntax, but I feel like we could do a whole talk about that. I didn't even accept the question because it's a never-ending discussion. But again, thank you, Stefan. Really interesting talk. We do have lunch, and there are sponsors. There is also the creator of Crossplane, actually, who's sponsoring the conference. So do go see the sponsors. They are the reason we can make this conference as great as it is. I mean, apart from you guys. Enjoy lunch.